What if the most stunning sights in the universe could also be the most treacherous? There's a strange duality to the cosmos where beauty and danger often go hand in hand. And nowhere is this more evident than in the enigmatic world of nebulae. These vast clouds of gas and dust, illuminated by the light of newborn stars or the remnants of dying ones, are cosmic masterpieces. But behind their dazzling displays lies a reality that's as perilous as it is captivating. Nebulas aren't just pretty backdrops in the night sky. They're dynamic, chaotic regions where the universe undergoes some of its most dramatic transformations. From the birth of stars to the explosive deaths of stellar giants, these celestial formations play a critical role in shaping the cosmos. And today, we're going to explore the most beautiful yet dangerous nebulae out there, places where the universe's artistry and raw power collide. So let's dive into the depths of space and uncover the secrets of these cosmic wonders, starting with one of the most mesmerizing nebulae ever discovered. Among the countless marvels scattered across the cosmos, few capture the imagination quite like the Orion Nebula. This celestial giant, located roughly 1,344 light-years from Earth, is a dazzling tapestry of color and light. Its swirling clouds of gas and dust are painted in vibrant hues of pink, blue, and purple, creating a scene that feels almost otherworldly. But the Orion Nebula isn't just a feast for the eyes, it's a cosmic factory, one of the most active star-forming regions in our galaxy. New stars are born here, emerging from the dense clouds of hydrogen and helium like fiery gems in the void. Yet for all its beauty, the Orion Nebula harbors a darker side. The very processes that create these stars also unleash immense and destructive forces. Intense radiation streams from its young, hot stars, bathing everything nearby in a torrent of energy. Stellar winds, powerful enough to strip away entire atmospheres, whip through the nebula at incredible speeds. These forces sculpt the surrounding gas and dust into intricate shapes, but they also make the region incredibly hostile. Even the building blocks of stars can be torn apart before they fully form. This duality, beauty and danger, is what makes the Orion Nebula so fascinating. It's a reminder that the universe is as unpredictable as it is stunning. And while it may seem like a distant spectacle, the Orion Nebula plays a crucial role in shaping our understanding of star formation. By studying its processes, scientists gain insights into how stars are born, how they evolve, and how they influence the galaxies around them. The Orion Nebula isn't just a sight to behold, it's a window into the very heart of creation itself. Among the countless wonders scattered across the cosmos, the Eagle Nebula stands out as a masterpiece of both creation and destruction. At its heart lies one of the most iconic cosmic structures ever captured by human instruments, the pillars of creation. These towering columns of gas and dust, stretching light years into the void, are a sight to behold, a nursery where new stars are born, cradled in the dense, cold embrace of molecular clouds. The pillars seem almost ethereal, their tendrils illuminated by the glow of young stars nestled within. But this beauty is not without its dangers. Surrounding the pillars are massive, luminous stars, their intense radiation carving into the nebula like cosmic sculptors. This process, known as stellar feedback, is both a creative and destructive force. While these stars help shape the pillars, they are also slowly eroding them, stripping away the very material needed to form new worlds. This delicate balance between creation and destruction is what makes the Eagle Nebula so mesmerizing and so perilous. Stellar feedback isn't just a passive process. It's a dynamic, ongoing event that shapes the fate of the nebula and everything within it. As we marvel at the pillars of creation, we're reminded that even in the vastness of space, nothing lasts forever. The forces at play here are a testament to the universe's ability to create breathtaking beauty, even as it whispers the inevitability of change and renewal. Nestled within the vast expanse of the Milky Way, the Carina Nebula stands as one of the most breathtaking sights in the universe. Its swirling clouds of gas and dust glow with vibrant hues, pinks, oranges, and blues, creating a cosmic masterpiece that seems almost otherworldly. But this beauty is more than just a visual spectacle. It's a dynamic region brimming with activity. At the heart of the Carina Nebula lie some of the most massive stars ever discovered, colossal giants that burn fiercely and live fast. These stars are not just awe-inspiring, they're also harbingers of destruction. Among them is Eta Carinae, a hypergiant star so massive and unstable that it's one of the most dangerous objects in our galaxy. Eta Carinae is a ticking time bomb, poised to explode in a supernova that could outshine entire galaxies for weeks. But it's not alone. The Carina Nebula is home to numerous massive stars, each with the potential to unleash a supernova capable of reshaping the surrounding cosmos. These explosions are both beautiful and terrifying, sending shockwaves through space and scattering elements essential for life itself. Yet, it's this very duality that makes the Carina Nebula so fascinating. Its luminous clouds of gas and dust serve as the birthplace of new stars, while the looming threat of supernova reminds us of the universe's raw power. The nebula is a place of creation and destruction, a cosmic dance that has been unfolding for millions of years. As we gaze at its splendor, we're reminded that the universe is not just a static painting. It's a living, breathing entity, constantly evolving and full of surprises. Nebulae are more than just breathtaking cosmic landscapes. They are the very cradles of new stars, acting as vast nurseries where the universe's next generation of stellar giants takes shape. Picture a dense cloud of gas and dust, millions of times larger than our solar system, slowly collapsing under its own gravity. This gradual process sets the stage for star formation, a delicate dance between compression and ignition. Within these colossal clouds, pockets of material begin to clump together, growing denser and hotter until they reach the critical point where nuclear fusion ignites, giving birth to a brand new star. But what makes nebulae such ideal star-forming factories? It's all about the ingredients. These cosmic clouds are rich in hydrogen, the primary fuel for stars, and dust particles that help shield the forming stars from disruptive external forces. The temperatures within these regions can vary dramatically, creating the perfect balance of pressure and density needed to trigger star birth. For instance, the Orion Nebula, one of the most well-known star-forming regions, is teeming with protostars, young stars still in the process of gathering mass and energy. Yet, star formation isn't just a straightforward event. It's a complex interplay of forces. Magnetic fields, turbulence, and even the shock waves from nearby supernova play crucial roles in shaping these cosmic nurseries. These factors can either accelerate the collapse of gas clouds or disrupt them entirely, leading to the birth of stars of varying sizes and lifespans. This intricate process ensures that no two star-forming regions are exactly alike, each contributing its own unique story to the tapestry of the universe. And as these stars are born, they begin to transform their surroundings, setting the stage for the next chapter in the life of a nebula. They illuminate the gas and dust around them, creating the glowing, colorful displays we often associate with these cosmic wonders. But their impact doesn't stop there. As stars age and eventually die, they release material back into space, enriching the nebula with heavier elements like carbon, oxygen, and iron. This cycle of creation and destruction turns nebulae into galactic recyclers, a topic we'll explore next. The Helix Nebula, often referred to as the Eye of God, is one of the most striking planetary nebulae in the cosmos. Located about 700 light-years from Earth, this celestial marvel is the glowing aftermath of a star that has reached the end of its life. As the star exhausted its nuclear fuel, it shed its outer layers, creating a breathtaking display of vibrant gases and intricate patterns. The Helix Nebula's haunting beauty, with its vivid colors and symmetrical structure, has captivated astronomers and stargazers alike. But beneath its stunning appearance lies a story of transformation, destruction, and renewal. At the heart of the Helix Nebula is a dying star, now a white dwarf, emitting intense ultraviolet radiation. This radiation ionizes the surrounding gas, causing it to glow in brilliant hues of blues, greens, and reds. While this process creates the nebula's mesmerizing visuals, it also poses a significant threat. Ultraviolet radiation from the central star can strip nearby planets of their atmospheres and sterilize any potential life forms. It's a stark reminder of the destructive forces at work in the universe, even as they create such awe-inspiring sights. But the Helix Nebula's story doesn't end with danger. As the remnants of the star disperse into space, they enrich the interstellar medium with heavy elements like carbon, nitrogen, and oxygen. These elements are the building blocks of new stars, planets, and even life itself. In this way, the death of one star becomes the birth of countless others, continuing the cosmic cycle of creation and destruction. The Helix Nebula offers a glimpse into the life cycle of stars, from their fiery beginnings to their graceful exits, and the profound impact they have on the universe. This interplay of beauty, danger, and renewal makes the Helix Nebula not just a wonder to behold, but a vital piece of the cosmic puzzle. Among the awe-inspiring nebulae scattered across the cosmos, each one tells a story, a chapter in the life cycle of stars. To truly appreciate these celestial wonders, we need to understand the journey of a star from its birth to its dramatic finale. Stars begin their lives within vast clouds of gas and dust known as stellar nurseries. These regions, like the Orion Nebula, are where gravity pulls together gas and dust, forming protostars that ignite into full-fledged stars upon reaching critical temperatures. Over millions or even billions of years, stars burn through their nuclear fuel, undergoing profound transformations. When a star exhausts its hydrogen supply, it swells into a red giant or supergiant, casting off layers of gas and dust into space. This ejected material forms the shells and tendrils we see in planetary nebulae, like the delicate Helix Nebula. For more massive stars, the end is even more spectacular. They explode as supernova, scattering their remains across the galaxy and leaving behind remnants like the Crab Nebula. This particular nebula, born from a supernova observed in the year 1054, stands out as a testament to the violent yet beautiful final act of a star's life. What makes the Crab Nebula unique is its pulsar, a rapidly spinning neutron star at its heart. This pulsar emits intense radiation, lighting up the surrounding nebula and creating one of the most dynamic and studied objects in the universe. By exploring these stages of stellar evolution, we not only witness the life cycle of stars but also connect the dots between the nebulae they create. Each nebula serves as a snapshot, capturing a star's journey and reminding us of the ever-changing nature of the cosmos. Among the most iconic and studied objects in the night sky lies the Crab Nebula, a breathtaking yet hazardous remnant of a star's explosive demise. This celestial marvel traces its origins back to the year 1054, when astronomers on Earth witnessed a brilliant supernova explosion. It was so intense that it could be seen during the day for nearly a month, a sight that would have been both awe-inspiring and terrifying. This event marked the death of a massive star, collapsing in on itself before erupting in a cataclysmic burst of energy. What remains today is a sprawling cloud of gas and dust, stretching over 10 light-years across, illuminated by the intense radiation from its core. At the heart of the Crab Nebula lies one of the universe's most fascinating yet dangerous objects, a pulsar. This rapidly spinning neutron star emits beams of radiation that sweep across space like a cosmic lighthouse. While pulsars are incredible to study, they also pose significant risks. Their intense magnetic fields and radiation can be harmful to anything too close, a reminder of the destructive power hidden within these beautiful remnants. The Crab Nebula serves as a stunning example of a supernova remnant, the aftermath of a star's explosive end. These remnants are not only visually striking but also play a crucial role in the cosmos. They scatter heavy elements like iron and gold into space, seeding the universe with the raw materials needed for new stars, planets, and even life. Yet their beauty comes with a caveat. Supernova remnants are not just relics of the past. They are active, dynamic regions filled with high-energy particles and radiation, making them both captivating and perilous. Among the most dramatic and transformative events in the universe are supernovas' explosions so powerful they can outshine entire galaxies for a brief moment. But what happens after the dust settles? The remnants of these colossal stellar deaths aren't just cosmic graveyards. They're dynamic forces that continue to shape the universe in profound ways. When a massive star explodes, it leaves behind a chaotic mix of gas, dust, and energy. These remnants, often expanding at incredible speeds, become nurseries for new stars and planets, seeding the cosmos with the building blocks of life. But they are also incredibly dangerous. The shock waves and radiation from supernova remnants can obliterate nearby star systems, sterilizing planets and disrupting the delicate balance of entire galaxies. Take the Tarantula Nebula, for example. This breathtaking region in the Large Magellanic Cloud is home to some of the most intense star-forming activity in the local universe, fueled in part by the remnants of ancient supernovas. The energy and materials left behind by these explosions have created a hotbed of stellar birth, but they've also carved out voids of destruction. The Tarantula Nebula is a perfect example of how supernova remnants can be both creators and destroyers, shaping the cosmos in ways that are as beautiful as they are terrifying. It's a reminder that even in the aftermath of chaos, the universe finds a way to build something new. Nestled within the Large Magellanic Cloud, a satellite galaxy of our Milky Way, lies the Tarantula Nebula, a cosmic marvel that both captivates and intimidates. Spanning over 600 light-years, this nebula is one of the most active star-forming regions known in our local universe. Its intricate web of glowing gas and dust forms a breathtaking tapestry, but beneath its beauty lies a chaotic and dangerous environment teeming with high-mass stars. These stars, many times more massive than our Sun, burn bright and fast, shaping the nebula with their intense radiation and powerful stellar winds. The Tarantula Nebula is a crucible of creation and destruction. Stellar winds, streams of charged particles ejected from these massive stars, sweep through the nebula at incredible speeds, sculpting the surrounding material into towering pillars and vast cavities. These winds can be both a force of life and death, triggering the collapse of gas clouds to form new stars while simultaneously eroding the very structures that nurture them. This dynamic interplay creates a volatile landscape where stars are born and vanished in the blink of a cosmic eye. Adding to the nebula's allure is its sheer luminosity. The Tarantula Nebula outshines even the Orion Nebula, the closest star-forming region to Earth, by a staggering margin. Its brilliance is fueled by clusters of young, hot stars that illuminate the gas clouds with vibrant hues of red, pink, and blue. Yet, this dazzling display is a reminder of the relentless energy released by these stellar giants, a testament to the raw power at play in this corner of the cosmos. As we gaze upon the Tarantula Nebula, we're witnessing a snapshot of the universe's most extreme processes where beauty and danger coexist in a delicate balance. It's a place where the forces of creation and destruction are intertwined, offering a glimpse into the life cycles of stars and the ever-changing nature of the cosmos. This nebula isn't just a sight to behold, it's a window into the turbulent heart of the universe itself. Now, let's turn our attention to one of the most dynamic forces shaping the cosmos' stellar winds. These powerful outflows streaming from the surfaces of stars within nebulae are both breathtaking and ferocious. Picture a star not as a static, glowing orb, but as a living entity, constantly exhaling streams of charged particles and gas into the void. These winds carry immense energy, sculpting the surrounding nebula into intricate shapes and patterns that captivate the eye. Yet, their beauty is matched by their destructive power, capable of ripping through clouds of gas and dust with incredible force. What makes stellar winds so fascinating is their dual nature. On one hand, they're creators, pushing and compressing material to trigger the birth of new stars. On the other, they're destroyers, eroding and dispersing the very structures that give nebulae their form. Imagine the winds of a hurricane, but on a cosmic scale, where speeds can reach millions of kilometers per hour and the temperatures soar to staggering heights. These winds don't just shape the physical landscape of a nebula, they also play a crucial role in the life cycle of stars, determining how they evolve and eventually die. But there's more to stellar winds than meets the eye. They're also a key player in the cosmic drama of radiation. As these winds collide with the surrounding interstellar medium, they generate shock waves that heat the gas, causing it to emit intense radiation across the electromagnetic spectrum. This radiation, invisible to the naked eye, tells astronomers a wealth of information about the processes at work within nebulae. It's a reminder that even the most violent forces in the universe have a role to play in the grand tapestry of creation, destruction, and renewal. As we explore these winds further, we'll see how they set the stage for understanding cosmic radiation, a phenomenon that connects the smallest particles to the largest structures in the universe. Stellar winds are not just a feature of nebulae, they're a window into the fundamental forces that shape our cosmos. Beyond their breathtaking beauty, nebulae are also some of the most energetic phenomena in the universe, emitting a variety of cosmic radiation that shapes the space around them. These emissions range from visible light to high-energy X-rays and gamma rays, each carrying its own unique signature and impact. For instance, ultraviolet radiation from young, massive stars within nebulae can ionize surrounding gas, causing it to glow in vibrant colors, like the brilliant reds and blues we see in the Orion Nebula. But it's not just light that these cosmic clouds produce. Nebulae are also sources of intense X-rays, often generated by supernova remnants or the interactions between charged particles and magnetic fields. This radiation doesn't just light up the void, it can also influence the formation of new stars and planets, sculpting the very fabric of the cosmos. One of the most fascinating examples of this interplay between radiation and structure is found in the iconic Horsehead Nebula. This dark nebula, located in Orion, is shaped by the powerful radiation from nearby stars. The ultraviolet light from these stars erodes the dense clouds of gas and dust, carving out the nebula's distinctive silhouette. The result is a stunning, shadowy figure that stands in stark contrast to the glowing hydrogen gas behind it. This process highlights how radiation isn't just a byproduct of cosmic activity, it's a force that molds the universe, shaping the celestial landscapes we marvel at from afar. As we continue to explore these radiant clouds, we're reminded that nebulae are more than just static snapshots in space. They're dynamic, ever-changing environments where radiation plays a starring role, driving the cycles of creation and transformation that define our universe. Among the countless wonders scattered across the cosmos, few are as instantly recognizable as the Horsehead Nebula. This striking formation, nestled in the constellation Orion, stands out for its dark, horsehead-like silhouette against a glowing backdrop of ionized gas. Its beauty is both haunting and mesmerizing, a testament to the delicate balance between creation and destruction in the universe. But what makes this nebula truly remarkable isn't just its iconic shape, it's the story it tells about the forces shaping interstellar space. The Horsehead Nebula's distinct silhouette is carved out by thick clouds of dust and gas, which block the light from the bright emission nebula behind it. This interplay of light and shadow creates an almost sculptural effect, as if nature itself has crafted a masterpiece. Yet this beauty exists in an environment that's anything but serene. The surrounding regions are bombarded by intense radiation from nearby stars, which ionizes the gas and causes it to glow in vibrant hues of red and pink. This radiation doesn't just illuminate the nebula, it also shapes it. Over time, the relentless energy from these stars erodes the dense dust clouds, slowly altering the Horsehead structure. It's a reminder that even in the vastness of space, nothing remains static. The very forces that make the Horsehead Nebula so breathtaking are also the ones that will ultimately change or even destroy it. What's especially fascinating about this nebula is how it serves as a natural laboratory for studying the effects of radiation on interstellar matter. Astronomers have observed how the intense ultraviolet light from nearby stars heats the gas, triggering chemical reactions that can lead to the formation of new molecules. This process not only influences the nebula's appearance, but also plays a crucial role in the birth of new stars and planetary systems. The Horsehead Nebula is more than just a celestial landmark, it's a symbol of the dynamic and ever-changing nature of the universe. Its iconic shape captures our imagination, while the harsh conditions surrounding it reveal the complex interplay of forces at work in the cosmos. As we gaze at this cosmic masterpiece, we're reminded of both the fragility and resilience of the structures that populate the vast expanse of space. Deep within the vast expanse of space, where stars are born and galaxies take shape, molecular clouds drift like cosmic cradles. These immense collections of gas and dust, primarily composed of hydrogen molecules, serve as the raw materials for some of the universe's most stunning and hazardous structures, nebulae. But what makes these clouds so extraordinary? Let's break it down. Molecular clouds are often referred to as stellar nurseries because they are the birthplaces of stars. Their dense pockets of gas and dust create the perfect conditions for gravity to take hold, pulling particles together until the pressure and temperature ignite nuclear fusion. This process not only forms stars but also gives rise to the vibrant, glowing nebulae that captivate our imaginations. However, these clouds are far from serene. Their turbulent interiors, filled with shockwaves from young stars and supernova, make them as volatile as they are beautiful. One such cosmic marvel born from these clouds is the Lagoon Nebula. Located about 4,000 light-years away, this nebula is a testament to the dynamic interplay of creation and destruction. Its glowing gas clouds, illuminated by the intense radiation of newly formed stars, reveal both the splendor and the peril of such environments. The Lagoon Nebula's intricate swirls of gas and dust are not just a sight to behold, they're a reminder of the sheer power at work in these regions of the universe. As we delve further into the Lagoon Nebula, it's important to remember that these molecular clouds, while essential for star formation, are also home to some of the most extreme conditions in space. From the searing heat of young stars to the crushing pressures of collapsing gas, these clouds are as dangerous as they are awe-inspiring. Understanding their role in shaping nebulae like the lagoon helps us appreciate the delicate balance between beauty and hazard in the cosmos. Nestled in the heart of the Milky Way, the Lagoon Nebula is a breathtaking tapestry of cosmic beauty and raw power. Spanning over 55 light-years across, this vast interstellar cloud glows with vibrant hues of pink and red, illuminated by the intense radiation of its newborn stars. At its core lies Herschel 36, a colossal star thousands of times brighter than our Sun, casting its light across the nebula and sculpting the surrounding gas into intricate shapes. These stellar nurseries are alive with activity, birthing stars at a staggering pace, but this beauty comes with a price. The stellar winds from these young stars are ferocious, tearing through the nebula at speeds that can strip away entire sections of gas and dust. This constant churning creates a chaotic yet mesmerizing environment, where energetic phenomena like shock waves and supernova remnants add to the nebula's dynamic nature. But the Lagoon Nebula holds even more secrets. Hidden within its swirling clouds are black holes, the enigmatic remnants of massive stars that have collapsed under their own gravity. These cosmic voids lurk silently, their immense gravitational pull shaping the nebula in ways we're only beginning to understand. The Lagoon Nebula is a reminder that even the most stunning corners of the universe can harbor unseen dangers, blending awe-inspiring beauty with the mysteries of the unknown. Nestled within the vast expanse of space, black holes are not just cosmic vacuum cleaners, they are architects of chaos and beauty. When these gravitational giants come into contact with nebulae, the results are nothing short of spectacular. The immense pull of a black hole can distort and stretch the clouds of gas and dust within a nebula, creating swirling patterns and intense radiation that illuminate the cosmos. This interplay between destruction and creation is a hallmark of their relationship, turning these regions into some of the most visually stunning yet dangerous places in the universe. Take, for example, the Veil Nebula. This sprawling structure is the remnant of a supernova explosion, a cataclysmic event that was likely influenced by a nearby black hole's gravitational forces. The shockwaves from the explosion rippled through the surrounding gas, sculpting it into intricate filaments and waves of ionized material. Today, the Veil Nebula shines with vibrant hues of red, green, and blue, a testament to the power of these cosmic interactions. But don't let its beauty fool you. The same forces that shape it also make it a perilous environment, where energetic particles and extreme temperatures dominate. Black holes don't just passively observe these processes, they actively shape the fate of the nebulae around them. Their gravitational pull can compress gas clouds, triggering the birth of new stars even as they devour others. This duality, where life and destruction coexist, makes regions like the Veil Nebula a fascinating subject of study. Understanding how black holes influence these celestial structures not only helps us appreciate their beauty, but also deepens our knowledge of the universe's most extreme environments. This dynamic relationship is a reminder that even in the vastness of space, every detail is connected, weaving a story of creation, destruction, and rebirth. Among the most breathtaking remnants of cosmic destruction is the Veil Nebula, a sprawling tapestry of glowing filaments stretching across the night sky. Born from the violent death of a massive star in a supernova explosion thousands of years ago, this nebula is a vivid reminder of the universe's capacity for both creation and destruction. Its delicate tendrils of ionized gas, illuminated in hues of red, blue, and green, weave an intricate pattern that resembles a cosmic spider's web, hauntingly beautiful yet fraught with danger. These filaments, while stunning, are far from serene. The same forces that sculpted the Veil Nebula also unleashed unimaginable energy, scattering shock waves and radiation across the cosmos. Even today, the remnants of that supernova can pose risks to nearby celestial bodies, a reminder that beauty in space often comes with a lethal edge. The Veil Nebula's structure is a testament to the chaotic aftermath of stellar death, where gas and dust are violently flung outward, only to slowly cool and form new structures over millennia. As we shift our gaze from the Veil Nebula, we enter the realm of dark nebulae, where the absence of light reveals a different kind of celestial wonder. Unlike their luminous counterparts, dark nebulae are dense clouds of gas and dust that block the light from stars behind them, creating shadowy silhouettes against the glowing backdrop of the Milky Way. These cosmic voids are not just empty spaces, they are nurseries of future stars where gravity slowly gathers material until it ignites into new life. The Veil Nebula and dark nebulae represent two sides of the same cosmic coin, one a remnant of stellar death, the other a cradle of stellar birth, each holding secrets to the universe's endless cycle of destruction and renewal. Have you ever gazed up at the night sky and noticed seemingly blank patches where stars refuse to shine? These are not empty voids but cosmic shadows cast by dark nebulae, dense clouds of gas and dust so thick they absorb the light of stars behind them. Unlike their glowing counterparts, these enigmatic formations are cloaked in mystery, appearing as silhouettes against the backdrop of the Milky Way. But don't let their shadowy appearance fool you. Dark nebulae are far from lifeless. Hidden within these clouds are secrets that could shape the future of entire star systems. One of the most intriguing aspects of dark nebulae is their potential to harbor dangerous radiation. As light is absorbed, it can ionize the surrounding gas, creating pockets of intense energy. These regions can emit harmful cosmic rays, making them hazardous to any nearby stars or planets. Yet, paradoxically, these same nebulae are also stellar nurseries. Under the right conditions, the gas and dust within a dark nebula begin to collapse under their own gravity, igniting the process of star formation. Over millions of years, these shrouded clouds can give birth to new stars, transforming darkness into light. But dark nebulae aren't exclusive to our galaxy. In fact, they can be found in distant galaxies, often playing a similar role in shaping their cosmic landscapes. Picture this: galaxies millions of light years away, each with its own collection of dark nebulae silently crafting the next generation of stars. These formations remind us that the universe operates on a grand scale, with processes that transcend the boundaries of any single galaxy. Whether they're blocking starlight, emitting radiation, or birthing new stars, dark nebulae are a testament to the dynamic and ever-changing nature of the cosmos. As we venture beyond the Milky Way, the universe reveals even more astonishing nebulae, each with its own story of creation and destruction. These cosmic clouds scattered across distant galaxies are not just beautiful, they're also windows into the violent and dynamic processes that shape the cosmos. Take, for example, the Tarantula Nebula in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. This colossal star-forming region is one of the most active in our galactic neighborhood, teeming with young, massive stars that light up the surrounding gas and dust in a dazzling display. Yet, within this beauty lies danger. Radiation from these stars can erode and destroy the very material that gave them life. But the Tarantula Nebula is just the beginning. In the Andromeda Galaxy, the closest spiral galaxy to our own, lies the Andromeda Nebula, a vast expanse of ionized gas that glows with the energy of countless stars. Here, too, the interplay of light and matter creates a spectacle of color and form. But it's also a reminder of the fragility of these structures. Supernova explosions, stellar winds, and even the gravitational pull of black holes can tear these nebulae apart, reshaping them into new and unexpected forms. What's even more fascinating is the role these nebulae play in galactic collisions. When galaxies collide, their nebulae are often the first to feel the impact. The gas and dust within them are compressed, triggering bursts of star formation on a scale that's almost unimaginable. These collisions can create some of the most stunning nebulae in the universe, but they also come with risks. The chaotic gravitational forces at play can fling stars and planets into the void, while the intense radiation from newly formed stars can sterilize entire regions of space. Galactic collisions are rare on a human timescale, but they're a fundamental part of the universe's evolution. They remind us that even the most beautiful phenomena in space are born from violence and chaos. As we explore these distant nebulae, we're not just witnessing the artistry of the cosmos, we're uncovering the processes that have shaped the universe for billions of years, and will continue to do so long after we're gone. As galaxies collide in the vast expanse of space, they unleash a cosmic ballet of creation and destruction, and nowhere is this more evident than in the fate of nebulae. These immense clouds of gas and dust become the canvas for some of the universe's most dramatic transformations. When galaxies merge, their gravitational forces pull and twist these nebulae into chaotic, swirling patterns, compressing them to trigger the birth of new stars. Yet, these same forces can also tear nebulae apart, scattering their material across the void. It's a paradoxical process where destruction fuels creation and chaos gives rise to beauty. This interplay is a reminder of the universe's dual nature, where even the most violent events can lead to breathtaking outcomes. the role of nebulae in these galactic collisions extends beyond the physical. Throughout human history, nebulae have captured our imagination, often woven into the myths and stories of ancient cultures. The Greeks saw them as the breath of gods, while indigenous peoples of the Americas viewed them as celestial pathways for spirits. These interpretations reflect humanity's attempt to make sense of the cosmos, blending science and storytelling. Even today, nebulae inspire awe, reminding us of our place in a vast and ever-changing universe. Their presence in both the physical and mythological realms bridges the gap between science and wonder, inviting us to explore not just the stars but the stories they inspire. Nebulae have long captivated the human imagination, not just as scientific marvels but as sources of myth and legend. Across cultures, these glowing clouds of gas and dust have been woven into stories that reflect both their ethereal beauty and their perceived dangers. In ancient Greek mythology, nebulae were often seen as the remnants of cosmic battles or the breath of gods, their swirling forms interpreted as omens or divine messages. The Orion Nebula, for example, was sometimes linked to the hunter Orion's legendary exploits, its radiant glow symbolizing his eternal presence in the stars. Similarly, in some Native American traditions, nebulae were thought to be the dwelling places of spirits, their shimmering beauty a reminder of the sacred connection between the heavens and the earth. Yet, these celestial formations were not always seen as benign. In many cultures, their unpredictable and often chaotic appearances were interpreted as signs of impending doom or upheaval. The Crab Nebula, with its pulsating energy and explosive origins, was sometimes seen as a harbinger of disaster, its restless glow a warning from the cosmos. These myths underscore a deeper truth. While nebulae are undeniably stunning, they are also regions of immense power and turbulence. Their formation often involves the death of stars, an event so violent it can reshape entire regions of space. These ancient interpretations, though rooted in imagination, reveal a profound understanding of nebulae's dual nature, both beautiful and dangerous. Today, as we study these cosmic clouds with advanced telescopes and probes, we're uncovering the science behind their mysteries, yet their allure remains as potent as ever. Moving forward, the future of nebula research promises to deepen our understanding of these celestial wonders, blending the awe of myth with the precision of modern science. As we look to the future, the exploration of nebulae is poised to enter a thrilling new era, driven by groundbreaking missions and cutting-edge technologies. Imagine the possibilities as telescopes like the James Webb Space Telescope continue to peer deeper into these cosmic clouds, uncovering secrets that have eluded us for centuries. Upcoming missions, such as the European Space Agency's Ariel and NASA's Nancy Grace Roman Space Telescope, are set to revolutionize our understanding of these celestial wonders, offering unprecedented detail and clarity. Yet, the journey ahead is not without its challenges. Nebulae are vast, complex, and often shrouded in dust and gas, making them difficult to study. But advancements in adaptive optics, artificial intelligence, and space-based observatories are helping us overcome these obstacles, allowing us to probe deeper into their structures and formation processes. One of the most exciting prospects is the potential discovery of new star-forming regions within nebulae, shedding light on how stars like our Sun are born. As we turn our gaze toward the Rosette Nebula, the promise of these technologies becomes even more apparent. This stunning nebula, home to a vibrant star cluster, offers a unique laboratory for studying the interplay between young stars and their surrounding gas clouds. With future missions, we may uncover how these stars influence their environment and how the nebula itself evolves over time. The Rosette Nebula's intricate beauty and scientific significance make it a prime target for exploration, and the discoveries it holds could reshape our understanding of the cosmos. Nestled within the constellation Monoceros, the Rosette Nebula stands as one of the most breathtaking yet hazardous regions in our galaxy. At its heart lies a dazzling cluster of young, massive stars known as NGC 2244, whose intense ultraviolet radiation carves out a vast cavity in the surrounding molecular cloud. This interplay of light and gas creates the nebula's iconic rose-like shape, earning it its poetic name. But don't let its serene appearance fool you. The Rosette Nebula is a place of extremes where beauty and danger coexist in stunning harmony. The central cluster's stars are not just luminous, they are also incredibly powerful, emitting radiation so intense that it ionizes the surrounding hydrogen gas, causing it to glow in vivid shades of red and pink. This same radiation, however, also drives a process called photoevaporation, stripping away the outer layers of nearby gas and dust. Over time, this relentless force sculpts the nebula's intricate structures, but it also poses a threat to any potential planet-forming regions within its reach. The Rosette Nebula is a reminder that even the most beautiful corners of the universe can be unforgiving. Adding to the complexity of this region is the presence of interstellar dust, tiny particles that scatter and absorb starlight, creating the nebula's darker, more mysterious zones. While this dust contributes to the Rosette's striking visual contrast, it also plays a critical role in the life cycle of stars. These particles act as the building blocks for new stars and planets, but they can also obscure our view, making it challenging for astronomers to study the processes happening within. The Rosette Nebula is a cosmic dance of creation and destruction, where light and darkness are locked in an eternal struggle. What makes this nebula particularly fascinating is its sheer scale. Spanning over 100 light-years, it's one of the largest such formations in the Milky Way, offering a glimpse into the vastness of stellar nurseries. Yet, for all its grandeur, the Rosette Nebula is also a fleeting phenomenon. The very stars that illuminate it will eventually exhaust their fuel, leading to supernova that will scatter their remnants across space. This cycle of birth, death, and rebirth is a testament to the dynamic nature of the cosmos, and the Rosette Nebula is a prime example of how even the most serene-looking regions can harbor incredible power and change. As we gaze at the stunning colors of nebulae, it's easy to overlook the tiny yet mighty force behind their brilliance: interstellar dust. This cosmic debris, made up of microscopic particles, is more than just space clutter. It's a key player in shaping the beauty and structure of these celestial wonders. When light from nearby stars hits this dust, it scatters in all directions, creating the vivid hues and glowing patterns we see. But don't let its artistry fool you. This same dust can also act as a double-edged sword, blocking light and obscuring the stars forming within these clouds. In the Omega Nebula, also known as the Swan Nebula, interstellar dust plays a starring role. This massive star-forming region is a bustling cradle of new stars, and the dust here is both a nurturing force and a formidable barrier. As young stars ignite, their intense radiation interacts with the surrounding dust, sculpting breathtaking pillars and cavities. Yet within these dusty clouds, the very process of star birth is hidden from view, shrouded by the same material that gives the nebula its striking appearance. It's a cosmic dance of creation and concealment, reminding us that even in the vastness of space, beauty often comes with complexity. Shifting our gaze to the Omega Nebula, also known as Messier 17, we find ourselves staring into one of the most active stellar nurseries in our galaxy. This region, located in the constellation Sagittarius, is a dazzling spectacle of gas and dust, illuminated by the intense radiation of newly formed stars. Its vibrant hues of pink, red, and blue are not just a feast for the eyes, but also a testament to the complex processes happening within. The Omega Nebula spans over 15 light-years, making it a massive cradle for star birth, but its beauty is matched by the dangers lurking in its depths. The nebula's glowing colors are primarily due to the ionization of hydrogen gas by ultraviolet light from massive young stars. These stars, some of which are dozens of times more massive than our Sun, blast out powerful stellar winds and radiation. While these forces sculpt the nebula into stunning shapes, they also create an environment that would be lethal to any form of life. The same energy that lights up the nebula can destroy planets or prevent them from forming entirely. It's a dynamic, chaotic space where creation and destruction coexist in a delicate balance. One of the most fascinating aspects of the Omega Nebula is its intricate structure, filled with pillars and filaments of gas. These formations are often the birthplaces of stars, as gravity pulls material together until it collapses into a new stellar core. However, these regions are also fraught with peril. Intense radiation and shock waves from nearby supernova can disrupt the delicate process of star formation or even tear apart the developing systems. It's a reminder that even in the vastness of space, nothing is truly safe or stable. Scientists study the Omega Nebula not just for its visual splendor, but also for the wealth of information it provides about the life cycle of stars. By analyzing the spectrum of light emitted by the nebula, researchers can identify the chemical elements present and understand the physical conditions within these star-forming regions. This data helps us piece together the puzzle of how stars are born, evolve, and eventually die, shaping the cosmos in the process. The Omega Nebula is more than just a beautiful sight. It's a window into the very forces that drive the universe. Spectral analysis is one of the most powerful tools scientists have to unravel the mysteries of nebulae. By dissecting the light these cosmic clouds emit, researchers can uncover the elements that make up their ethereal structures. Each element leaves behind a unique fingerprint in the form of spectral lines, allowing us to identify hydrogen, helium, oxygen, and even more exotic compounds like nitrogen or sulfur. This process not only reveals what nebulae are made of, but also provides clues about their temperature, density, and movement through space. The results are like a cosmic chemistry lab, where every color and wavelength tells a story about the life and death of stars. But spectral analysis isn't just about uncovering the building blocks of these celestial wonders, it also highlights their dangers. For example, the intense radiation emitted by some nebulae can strip atoms of their electrons, creating highly charged plasma. This plasma can be hazardous to any nearby objects, including spacecraft or even hypothetical future explorers. By studying these emissions, scientists can map out the most volatile regions of a nebula, understanding where its beauty masks potential threats. Take the Cat's Eye Nebula, for instance. Its intricate, almost sculptural appearance hides a turbulent core where stellar winds and radiation collide in chaotic bursts. Spectral analysis reveals layers of gas being ejected at incredible speeds, painting a picture of a dying star in its final, violent stages. This nebula's complexity serves as a reminder that even the most breathtaking objects in the universe can harbor unseen dangers. As we continue to explore these cosmic phenomena, spectral analysis remains our window into both their elegance and their peril. Among the countless wonders scattered across the cosmos, few captivate the imagination quite like the Cat's Eye Nebula. This celestial masterpiece, located approximately 3,000 light-years away, is a stunning example of a planetary nebula, though its name can be a bit misleading. Unlike planets, these nebulae are the glowing remnants of dying stars, their outer layers expelled into space in a breathtaking display of cosmic artistry. The Cat's Eye is particularly famous for its intricate, almost symmetrical structure, resembling the pupil of a feline eye. Its delicate rings and radiant hues of blue and green make it one of the most visually striking objects in the night sky. But don't let its beauty fool you. The Cat's Eye Nebula is also a testament to the raw power of stellar evolution. At its core lies a white dwarf, the dense remnant of a star that once burned brightly. This tiny, incredibly hot object emits intense ultraviolet radiation, which energizes the surrounding gas, causing it to glow. While this process creates the nebula's dazzling appearance, it also means the Cat's Eye is a place of extreme conditions. The radiation and stellar winds from the central star sculpt the surrounding material into its iconic shapes, but they also signify the violent end of a stellar life cycle. What's particularly fascinating is how nebulae like the cat's eye interact with their environment. The material expelled by the dying star doesn't just float aimlessly in space it collides with, heats up and shapes the surrounding interstellar medium. This interaction can trigger the formation of new stars and even influence the evolution of entire galaxies. It's a reminder that even in death, stars play a vital role in the cosmic ecosystem, seeding the universe with the elements needed for future generations of stars and planets. The Cat's Eye Nebula, with its intricate design and powerful emissions, serves as a vivid example of this ongoing cosmic dance, a dance that continues to shape the tapestry of the universe. As we peer deeper into the cosmos, the dynamic relationship between nebulae and their environments reveals a breathtaking interplay of beauty and peril. These vast clouds of gas and dust don't exist in isolation. They're constantly shaping and being shaped by the space around them. Stellar winds, shock waves from supernova, and even the gravitational pull of nearby stars all play a role in sculpting these cosmic marvels into the intricate forms we observe. This interaction often results in stunning visual displays, like the swirls of color in the Orion Nebula or the delicate tendrils of the Veil Nebula. But don't let their beauty fool you. These processes can also create some of the most extreme conditions in the universe. One of the most fascinating examples of this interaction is the birth of new stars within nebulae. Dense pockets of gas collapse under their own gravity, igniting nuclear fusion and giving rise to young, energetic stars. These newborn stars, in turn, emit intense radiation and stellar winds that push against the surrounding material, carving out cavities and triggering further star formation. It's a cycle of creation and destruction, where the very forces that bring stars to life also tear apart the structure of the nebula itself. And sometimes these interactions can lead to explosions so powerful they outshine entire galaxies. But not all nebulae are sites of star formation. Planetary nebulae, for instance, mark the end of a star's life rather than its beginning. When a star like our Sun exhausts its nuclear fuel, it sheds its outer layers into space, creating a glowing shell of gas that expands outward. This material interacts with the surrounding interstellar medium, forming intricate patterns that can resemble everything from rings and bubbles to more complex, asymmetrical shapes. Though they're called planetary nebulae, they have nothing to do with planets. The name comes from their round, planet-like appearance in early telescopes. Still, their beauty is undeniable, and they serve as a reminder that even in death, stars leave behind a legacy of light and color. However, these interactions aren't just visually stunning, they can also be incredibly hazardous. The intense radiation from young stars or the remnants of dying ones can strip away atmospheres from nearby planets, making them inhospitable to life. Meanwhile, shock waves from supernova can compress gas clouds, triggering new star formation, but also sending destructive ripples through the cosmos. This duality of creation and destruction, beauty and danger, captures the essence of what makes nebulae so captivating. They remind us that the universe is not a static place but a dynamic, ever-changing tapestry of forces at work. Planetary nebulae are among the most visually stunning phenomena in our universe, but their beauty comes with a twist. These glowing clouds of gas and dust are the remnants of dying stars, shedding their outer layers in a spectacular cosmic finale. As the star exhausts its nuclear fuel, it swells into a red giant, then expels its outer material into space, creating intricate patterns that shimmer with vibrant colors. Yet, this process isn't just about aesthetics, it's a violent transformation. The intense radiation from the dying star ionizes the surrounding gas, causing it to emit light in vivid hues. But within this beauty lies danger. The same radiation that lights up the nebula can also destroy nearby planets or celestial objects that venture too close. One of the most captivating examples of a planetary nebula is the Bubble Nebula. Its nearly perfect spherical shape, formed by stellar winds pushing against interstellar material, makes it a cosmic icon. The delicate structure appears almost like a soap bubble floating in space, but its formation is anything but gentle. The central star, burning at extreme temperatures, emits powerful winds that sculpt the surrounding gas into this stunning form. Yet, these winds are so intense that they can strip away the atmospheres of any planets orbiting nearby. The Bubble Nebula serves as a reminder that even the most breathtaking sights in the universe are often born from chaotic and destructive processes. As we explore these celestial wonders, we're reminded of the delicate balance between creation and destruction that shapes the cosmos. As we venture further into the cosmos, the Bubble Nebula stands out as one of the most visually striking phenomena in the universe. Picture a delicate, shimmering sphere floating in the vastness of space, its surface glowing with an almost ethereal light. This cosmic bubble, officially known as NGC 7635, isn't just a random formation, it's the result of an intense interplay between a massive star and the surrounding interstellar medium. At its heart lies a fiercely luminous star, emitting radiation so powerful that it pushes the surrounding gas and dust outward, sculpting the nebula into its iconic shape. What makes the Bubble Nebula particularly fascinating is the force behind its creation: stellar winds. These are streams of charged particles ejected from the central star at mind-boggling speeds, reaching up to millions of miles per hour. Imagine a celestial artist relentlessly blowing into a cosmic canvas, shaping and reshaping the material around it. These winds carve out the bubble, while the star's ultraviolet radiation ionizes the gas, causing it to glow in vivid hues of blue and white. This process isn't just beautiful, it's a testament to the sheer power of stellar activity and its ability to transform entire regions of space. But the story doesn't end there. The Bubble Nebula also serves as a gateway to understanding the broader impact of stellar radiation on the cosmos. Beyond shaping nebulae, this radiation plays a crucial role in the life cycle of stars and the evolution of galaxies. It can trigger star formation in nearby clouds of gas, or it can strip away material, preventing new stars from emerging. This duality, creation and destruction, is a recurring theme in the universe, and the Bubble Nebula is a perfect example of how stars shape their surroundings in profound ways. As we delve deeper, we also begin to see the influence of cosmic rays, high-energy particles that travel through space at nearly the speed of light. These rays, often accelerated by supernova or other energetic events, interact with the material in the Bubble Nebula, adding another layer of complexity to its dynamic environment. They help ionize the gas, contributing to the nebula's glow, and they play a role in the chemical processes occurring within it. Together, stellar winds, radiation, and cosmic rays create a cosmic symphony, each element playing its part in the grand design of the universe. The Bubble Nebula isn't just a stunning sight, it's a living laboratory offering insights into the forces that shape our universe. It reminds us that even in the vastness of space, every star, every particle, and every ray of light is part of an intricate, interconnected system. And as we continue to study these celestial wonders, we uncover not just the secrets of the cosmos, but also our place within it. Nebulae, those vast clouds of gas and dust scattered across the cosmos, are not just serene havens of light and color. They're also battlegrounds where invisible forces wage a relentless war. One of the most powerful yet unseen players in this cosmic drama, cosmic rays. These high-energy particles, traveling at nearly the speed of light, are far more than just space oddities. They play a crucial role in shaping, and in some cases, endangering the very fabric of nebulae. When cosmic rays collide with the material in a nebula, they don't just pass through quietly. They interact violently, transferring their immense energy to the surrounding gas and dust. This energy can heat up the nebula's material, ionize atoms, and even trigger the formation of new molecules. In some ways, cosmic rays act like cosmic sculptors, molding the structure of nebulae in ways that can lead to the birth of stars and complex organic compounds. But there's a darker side to their influence. The same energy that fuels creation can also sow destruction. The intense radiation from cosmic rays can strip electrons from atoms, creating highly charged particles that destabilize the nebula's delicate balance. In extreme cases, this can lead to the fragmentation of the nebula, disrupting its ability to form stars and threatening its very existence. It's a constant tug of war between creation and destruction, played out on a scale that's almost impossible to comprehend. What's fascinating is how these cosmic rays originate. Many are born from supernova, the explosive deaths of massive stars. When a star explodes, it doesn't just vanish, it sends shockwaves through space, accelerating particles to unimaginable speeds. These particles, now cosmic rays, travel across the galaxy, embedding themselves into the heart of nebulae and continuing the cycle of creation and destruction. It's a reminder of how interconnected the universe truly is, with every event rippling through space and time. As we unravel the mysteries of cosmic rays and their effects, we're also reminded of the delicate balance that governs the cosmos. Nebulae, for all their beauty, are not immune to the chaos that surrounds them. They are shaped by forces we're only beginning to understand, and their survival often depends on the interplay of energy, matter, and time. This intricate dance sets the stage for the next chapter in our exploration of the universe's most breathtaking and perilous phenomena. Among the most fascinating aspects of modern astronomy is the way we now study nebulae, those breathtaking clouds of gas and dust scattered across the cosmos. Advanced observational techniques have revolutionized our understanding of these celestial wonders, allowing us to peer deeper into their intricate structures than ever before. Take, for example, the use of adaptive optics, a technology that corrects distortions caused by Earth's atmosphere in real time. This innovation has given us crystal-clear images of nebulae, revealing details like swirling filaments and shockwaves from dying stars that were once hidden from view. Without this leap in technology, much of the intricate beauty and danger of these formations would remain a mystery. Another groundbreaking method is spectroscopy, which allows scientists to analyze the light emitted by nebulae. By breaking down this light into its component wavelengths, researchers can determine the chemical composition of a nebula, as well as the temperatures and velocities of its gases. This isn't just about identifying elements like hydrogen or helium. It's about understanding the dynamic processes at work, such as the intense radiation from nearby stars or the explosive remnants of supernova. These insights not only deepen our appreciation of nebulae, but also highlight the hazardous environments they create, environments where radiation and extreme temperatures could obliterate anything that ventured too close. Then there's the role of space-based observatories like the Hubble Space Telescope and the James Webb Space Telescope. Free from the interference of Earth's atmosphere, these instruments capture stunning high-resolution images and infrared data, revealing nebulae in wavelengths invisible to the human eye. The James Webb Telescope, in particular, has opened a new window into the universe, allowing us to see the earliest stages of star formation within these clouds. These observations are not just about beauty, they're about understanding how nebulae shape the life cycle of stars and galaxies, influencing the very fabric of the cosmos. Looking ahead, the future of nebula studies is filled with promise. Upcoming missions and technologies, such as the Nancy Grace Roman Space Telescope and advanced machine learning algorithms for data analysis, will push the boundaries of what we can observe and comprehend. These tools will not only enhance our ability to study nebulae, but also help us predict their behavior, such as where and when new stars might form or how supernova remnants might evolve. As we continue to refine these techniques, we're not just uncovering the secrets of nebulae, we're redefining our understanding of the universe itself. As we delve into the broader implications of nebula research, it becomes clear that these cosmic phenomena are far more than just stunning visual spectacles. They are pivotal players in the grand narrative of the universe, shaping the very fabric of existence. The study of nebulae offers astronomers a unique window into the dual forces of creation and destruction that govern cosmic life cycles. When we observe these vast clouds of gas and dust, we're witnessing the birthplaces of stars and planetary systems. But this process is not one-sided. Nebulae also mark the end of stellar life as dying stars expel their outer layers, enriching space with the building blocks for future generations. This delicate balance between creation and destruction is a cornerstone of our understanding of the universe. It's a reminder that every end is a new beginning, and every beginning carries the echoes of what came before. Beyond their role in stellar evolution, nebulae also serve as cosmic laboratories. They allow scientists to study the physical and chemical processes that occur under extreme conditions that are impossible to replicate on Earth. From the formation of complex molecules to the behavior of magnetic fields in space, nebulae provide invaluable insights that deepen our comprehension of the cosmos. What's more, these celestial wonders act as natural telescopes, magnifying the light of distant objects behind them. This phenomenon, known as gravitational lensing, helps astronomers peer farther into the universe than ever before, uncovering secrets of galaxies and phenomena that would otherwise remain hidden. As we move into the final showcase of these breathtaking cosmic structures, it's worth reflecting on how nebulae connect us to the universe's past, present, and future. They are not just distant wonders to admire, but also key pieces in the puzzle of cosmic evolution. Each discovery brings us closer to answering fundamental questions about our origins and the destiny of the cosmos. This balance of beauty and danger, creation and destruction, is what makes nebulae so captivating. They remind us that the universe is a dynamic, ever-changing tapestry, and we are privileged to witness even a small part of its unfolding story. As we reach the pinnacle of our journey through the cosmos, let's take a moment to marvel at the breathtaking gallery of nebulae that illuminate the universe. These celestial masterpieces, painted across the vast canvas of space, are not just scenes of beauty, they are the very engines of creation and destruction. Each one tells a story of life, death, and rebirth, reminding us of the delicate balance that governs the cosmos. First, we have the Orion Nebula, a stellar nursery where new stars are born amidst swirling clouds of gas and dust. Its vibrant hues of pink and blue are a testament to the raw energy of creation. But just as it gives life, it also consumes as the intense radiation from its young stars erodes the surrounding material, shaping the nebula into its iconic form. Not far away lies the Carina Nebula, a colossal expanse of glowing gas and towering pillars. Its towering structures, like cosmic skyscrapers, are both majestic and fragile, constantly sculpted by the winds of nearby stars. Then there's the Crab Nebula, the remnants of a supernova explosion that was witnessed on Earth nearly 1,000 years ago. Its intricate filaments and pulsating heart of a neutron star serve as a stark reminder of the destructive power of the universe. Yet, even in its chaos, it seeds the cosmos with the elements necessary for new stars and planets to form. And who could forget the Helix Nebula, often called the Eye of God? Its hauntingly beautiful structure, with its central star shedding its outer layers, represents the final act of a star's life, a process that will one day replenish the galaxy with fresh material. These nebulae, each with their own unique characteristics, are more than just celestial wonders. They are the architects of the universe, shaping the destiny of galaxies and the very fabric of space itself. They remind us that beauty and danger are often intertwined, and that the cosmos is a place of constant transformation. As we reflect on these stunning displays, we're left with a profound appreciation for the forces that shape our existence and the mysteries that still await discovery. As we gaze into the vast expanse of the universe, nebulae stand as both breathtaking wonders and formidable reminders of nature's dual nature. These cosmic clouds, with their swirling colors and intricate formations, are not just stunning visual spectacles, they are the very cradles of stars and the remnants of stellar death. They shape the cosmos, recycling matter and energy in an endless cycle that fuels the birth of new worlds and systems. Yet, within their beauty lies danger, with intense radiation, powerful magnetic fields, and chaotic environments that would obliterate anything that ventured too close. Nebulae remind us of the delicate balance that governs the universe: creation and destruction, beauty and peril, all intertwined in a dance that has been ongoing for billions of years. They invite us to ponder our place in this grand tapestry, a tiny speck in a cosmos teeming with both life-giving potential and destructive force. As we continue to explore these celestial marvels, we uncover not just the secrets of the universe, but also insights into our own origins and destiny. So, as we marvel at the awe-inspiring images of nebulae captured by telescopes, let's ask ourselves this: in a universe so vast and filled with both wonder and danger, what does it mean to be human? How do we fit into this cosmic story, and what role do we play in the unfolding narrative of the stars? The journey of discovery is far from over, and with every new observation, we take another step toward understanding our place among the stars. The universe beckons. Will we answer its call?